So, well, hello, Frankie here, speaking, giving you a quick demonstration on t- how if you have a switch and you have more than one VLAN or even more than one subnet, as we have in this example here, we have VLAN 1 and VLAN 2, and IP subnets from 192.168.1 and 10.0.0.1, then there may be a situation where you want to traverse them. Usually you can't. With this configuration here, you can't anyway, because all we have here is a layer 2 switch, which will prevent us from doing that. It will keep these two networks very separate, and we will not be able to route from one to another. So, how would you do this? As is, you simply can't without the use of some form of routing information. So we're going to add one. You can get them quite cheaply nowadays. Get them off eBay or whatever. And I always get a Cisco, although you can get others. There are some very, very good makes out there. Fast Iron do a pretty good one. But I'm working with Cisco today, so I'm going to show you how to get started on a very, very basic configuration with a Cisco router. This is called router on a stick because it's literally a plug-and-play thing. Well, I say literally a plug-and-play thing. It does require some configuration for it to work. Now, this is already set up with two VLANs. It's already configured. These IP addresses are already set up. And to give you a demonstration, we'll run this in real-time mode. So we'll give you a demonstration of this one onto desktop, and we'll try pinging this machine over here, 10.0.0.1. I can tell you already it won't make the journey. You see I've already tried to ping earlier. 10.0.0.1, and it will fail. As you can see yourself. If you're used to this software, you already know how to use it, but if not, it's called Packet Tracer. It's free, it's from Cisco, and there is currently a student version, which is the full version. All you need to do is sign up for their course, which you can do on their website. And it seems pretty much unlimited. It's not as robust or as feature-filled as, say, GNS3, but it's got everything you want for diagnosing networks. So anyway, I'll show you this facility here. You can run into simulation mode, and I've turned all filters off except ICMP. Play around with it, you'll figure out how to do it. And we'll do a ping using the simulation. Just an average simple ping or a simple PDC from that to that, and as you can see, it's stopped already. And when you click on that, it gives you well, it would normally give you the full 7-layer protocol here, but it's, you can see 1 2 3 4 5 6 7 layers in and 1 2 3 4 5 6 7 layers out. It's giving you a layer 3 ICMP message, basically saying that it can't reach because it's in a different subnet. It's also in a different VLAN, so it won't reach anyway. But there's if you're using separate VLANs, it's always best to use separate subnets, as it can cause complications in the long run. So I'm going to give you a very simple method of using one of these Cisco routers to actually traverse from one VLAN or one subnet. In this case, in fact, we're going to solve both in one fell swoop here. So as I say, we have 192.168.1 network on 24 bits, and we have a 10 network on 8 bits. And you could no doubt these can ping it. That one can ping that one. That can ping that one, and this one can ping that one, and that one can ping that one. But as you can see, they can't go over from one to the other. So we'll configure this little route on a stick, which is which basically is just grab a Cisco router, and we hook it in to this switch here, like this. We'll put it on port 24. Right, that should work. Right, okay. It's currently red, which means it's not physically up. Oh, I need new teeth. Right, before we can go any further, this is already configured to talk to these via VLAN. Well, as I say, these are all configured on separate VLANs. So we now need to negotiate a little bit of chatter between the router and the switch. So on the switch first, we will set it's plugged into port 24, as you can see here, fast Ethernet port 24. So we will go into, actually I'll take you from the beginning in case you don't know how to do this. So you go enable. Oops. No. If you end up trying to do DNS lookup, which you just tried to do there, just press Shift, Control and 6 on an actual router and it will stop. Otherwise you'll be waiting forever. So I'll try this again. Enable without the D. Spell it right this time. There we are. Config T. It means config terminal. Now we're in global configuration mode. Now we need to go into interface fast Ethernet 24. Is it right? 0.024, 0/24. And we need to configure it as a trunk port. Switch mode. Port trunk. Switch mode. Switch port, sorry, switch port mode. Switch port mode trunk. Turns that into a trunk port, which allows it to carry any VLAN through that particular line, which it will need to do to talk to that router the way we want it to. Right, here we have only one cable, and we're going to send 2 lots of VLAN down to this one port. How do you do that, I hear you ask? Well, actually I don't, but just in case. Right, so that's fast Ethernet 0, 0. Now that router does have 2 fast Ethernet ports on it, but on many occasions you'll get one with just the one, and you need to be able to deal with that. So we're going to do that. We're going to assume for the moment that this router only has one fast Ethernet port. So we need to go into enable like we did on the switch. Config terminal, and we need to assign IP addresses to this port. Firstly, we need to turn the port on, so no shutdown would switch fast Ethernet 00 on. No shutdown. I'm spelling that right. Oh, I'm not in the you can tell it's Sunday. So we need to go into that port, fast Ethernet 0/0. There we are. We're in there now. We do no shutdown, which should actually switch that port on. See, now it's changing from amber. It'll go green in a minute, but it still will have no way of talking to the switch because it has no IP address or anything. So we're now going to create 2 virtual ports. Each one will have its own IP address. So we'll go for interface fast Ethernet 0.1. Now that'll create a virtual port, a sub-internet interface, if you will. And that one we shall use to talk to VLAN 1. And so we'll go for IP address. No, we won't. It will give me an error if I type it straight away. We first have to set something on called encapsulation, which basically tags a VLAN number to every packet it sends out, which will allow you to transmit packets to multiple VLANs. .1q, that's what we want. And we need to set the VLAN number, in this case 1. So what that means is that every packet it sends through this sub interface will be tagged with a VLAN of 1, which is the default VLAN on most cases. And now we need to add an IP address which matches the subnet of VLAN 1. So we're going to call it 10.0.0.254. Now we need to add a subnet mask as well, 255.0.0.0. That has to match the subnet here as well, which as you can see is 8-bit. And away we go. Now that should be okay there. Now we can come out of that, not end, I want exit. And we need to create the other virtual subnet sub interface, which we'll call subnet fast Ethernet 0.0.2 VLAN 2. They don't have to match, it's just makes more sense if they do. And we'll do the encapsulation again, only this time we want to tag our packets with VLAN 2 ID, which we've done. And now we'll set the IP address to match the subnet on VLAN 2, which is 192.168.1.254. That 254 is just a free address which isn't used because we're going to be using that as a gateway for the client PCs to talk to. Remember 255.255.255. Can't even see 0.255. No. 0.0. 0.0. Looks like an O. Oh well, yeah, there we are. And we can come out of that. Now, before we do anything else, we can close that down, and we need to tell each of these PCs that we're now going to be using that as a gateway. I still don't know why that's orange. Right, so fast Ethernet. So 10.254, because this is on VLAN 1 and it's the 10 network, so we use the 10.254 gateway. Same with this one, 10.0.0.254, because they're both on the same VLAN. This one will be on the other gateway, which is 192.168.1.254, and so will this one. One 192.168.1.254. We leave DNS blank because we're not resolving domain names. I wonder if it's because we're in simulation mode. Oh yes, there you go, look. It's gone from amber to green. So, now, delete that. Now what we can do is because we're no longer in simulation mode, we're in real time, we can try an actual ping over to one of these, from VLAN 2 to VLAN 1. So we'll try, I'm in the wrong one, there we go, command prompt. Okay, you can see here I already did one earlier, so here's one I made earlier, so we'll try again. Ping in. Request timed out. Now why is that request timing out, I hear you ask? It should certainly be making it to so this is the beauty of this software. You can go into packet stuff. You can go into the packet and use simulation mode to see exactly what's going on. So we're now in simulation mode. So we'll send a ping again from there to there. Now it's not giving me the big X this time. So we'll take a step forward. And it's giving me the X. Why is that? Layer 2. Request times out. The IRP drops the packet. Now that's odd because the IRP drops the packet. So we'll reset the simulation. Turn on ARP. Edit filter ARP. Now get rid of that again. We'll send a brand new fresh ping, which will go there. See now, pull this over, ARP, you see the ARP goes up, it's going up to there, and you click on that and it tells you what's happening. It sees the frame, broadcast post sends the frame to all ports except the receiving port, sends out the frame, so it's basically send out an ARP request which goes to all ports. Now that router is rejecting it. What's the receiving port? Receiving port is different. Hang on. To show IP. Right, 10.0.0.2548, which is on Fast Ethernet 0.01, which is right, and is up 192.168.1. Is that 158? Have I typed the IP address in wrong? I have. You see, this is the beauty of this software. You can diagnose your network. I've typed the IP address in wrong, haven't I? So hang on, so we'll go and config T again. And we shall, put my glasses on, it might help. And we shall, oh dear. Okay, there we go, look. I can see it's on the Fast Ethernet 0.0.2, IP address 192.158. Here we go. I'm going to change that to 168. Right, I'm going to end. We'll try that again. Okay, in progress. Right. Okay, we can delete that. Reset simulation and go to real-time mode. We'll try again, shall we? There's my eyes. No, other one. Oh well, we'll try it from this one. Ping 10.10.0.0.1. Still not having it, is it? Request time. Oh no. Oh, did you see that? Oh yes. Received lost 1. 25% packet lost. Try that again. Yes, there we are. Yes, the first one would have been lost due to ARP handshaking. Aha. So yeah. So now from this one we've pinged the other VLAN on a different subnet on a different VLAN. We'll try this one as well. This one will no doubt have the same issue. Remember we tried this one already. Oh no. Because the IRP has already been resolved on the. Yeah, that's right. No rules. So basically, then we don't need to try pinging back because we already know it's they're talking to each other. But if you want to play with a simulator, have a look on the simulator how they do it. You can go for. Let's have a crack at this, shall we? So we'll send a packet from there to there. Now this is how it works. Yeah. Now we've left ARP on, but it doesn't really matter, because it shouldn't be asking because it's already resolved. So it's going there, goes to the router, and the router basically tells it how to get to the other VLAN and other subnet, which you can see everything's going through the router, and it gets back there. So the successful ping there. It's not giving the tick, but that is a successful ping. Anyway. I hope you've enjoyed this lesson or this tutorial. If you like it, please approve. Oh look, I've got the tick, which has been approved, which means it's approved the ping. if you like what you've heard, this is my first ever video, so if I seem a bit stuttery, it's just because I need more practice. But if you like what you've heard or seen, then please give me a like. Thank you so much.